Hello everybody, it's Dumplet here. Here's an item on trigonometry. Evaluate the following. The inverse tangent of the quantity square root of 1 plus sine 192 degrees all over 1 minus sine 192 degrees. As usual, pause this video if you'd like to give this item a try. But if you're done, let us dive into the solution. Now, the first thing we want to consider here is maybe you want to make the angle a little bit smaller so it's easier to work with. Now, since we know that the inverse tangent, it only outputs, so it only ranges from negative 90 degrees to 90 degrees, and 192 is out of this range. So let's try to write it in terms of something else. So let's consider the following identity: sine 180 plus x, that's equal to negative sine of x. Now this is very simple. All you have to do if you want to prove this statement, simply expand this via the addition rule. Now since we have sine 180 plus x equals sine x, we can easily replace all of the sine 192 degrees. We can replace it with negative sine 12 degrees. And this is the substitution we're going to make. So we're going to end up with this. So the inverse tangent of the square root of 1 minus sine 12 degrees all over 1 plus sine 12 degrees. Next, let us write everything in terms of cosines. Why? It's because of the motivation that we have the following identity. We have the identity for the half angle of tangent. So tangent theta over 2, we can write it as positive or negative square root of 1 minus cosine theta over 1 plus cosine theta. Now, since sine and cosine are very much related, and the only difference with this form and the square root inside of this expression is that all the cosines are replaced with sines, but that's no problem. We can easily replace sine 12 degrees by cofunction identity. We know this is equal to cosine of the complement of 12, so cosine 90 minus 12, which is 78 degrees. So we can replace all the sine 12s with cosine 78 degrees, and this will be the result. Next, I mentioned that we have the identity for the half angle of the tangent. So tangent theta over 2, that is equal to the square root, so plus or minus square root of 1 minus cosine theta over 1 plus cosine theta. Now, so since we have theta, if we have theta to be 78, then we know that this expression in the middle, this would be tangent, this would be equal to tangent of 78 degrees over 2, which is 39 degrees. Now, obviously, we should take the positive sign since the 78 degrees, it has a terminal side at quadrant 1, so we know the tangent there is positive, and we can conclude that this square root is equal to tangent 39. So we can write it alternatively as follows. So we can write cosine 78 as using the cosine double angle identity. We have cosine 78 degrees. That's equal to 2 cosine squared, half of this angle, which is 39, minus 1, and we can write this in terms of sines as well. 1 minus 2 sine squared, 39 degrees. So if we replace the cosine 78 in the numerator with this, and we replace the cosine 78 in the denominator with this, we know that the numerator will simplify to 1 minus the quantity 1 minus 2 sine squared 39. So the numerator becomes 2 sine squared 39 degrees, and the denominator would be equal to 2 cosine squared 39 degrees. So either way, we'll end up with the answer of the tangent, since we know that the 2's will cancel. The sine squared 39 divided by cosine squared 39, we know this is equal to tangent squared 39. So either way, we're going to end up with the square root of tangent squared 39, which will give us tangent 39 degrees. Now, all you have to do is get the inverse tangent of 39 degrees by the property of inverse functions. The inverse of a function will just be the input. So we have the answer here to be 39 degrees. And this will be our final answer. Hopefully you guys learned something new from this video, and I'll see you in the next one. Bye-bye!